video, I'm going to explain the different arrow pushing conventions. Arrow pushing is a tool that shows how bonds form and break in a reaction. And there's basically two different steps or conventions. The first one states that arrows must always begin at an electron pair. And this makes sense because this arrow is showing you where this electron pair is moving. We have two different types of arrows we'll use for arrow pushing conventions. The first arrow is the regular curved arrow, which stands for two electrons moving, so one electron pair. The second arrow looks like a hook, which makes the difference between these two arrows. So the sharp end has only one edge, and that stands for one electron moving. So now the first steps makes more sense. We know that these two arrows stand for electron movement, therefore we need them to begin at an electron pair. Now the second step states that arrows point to the desired location of a new bond or a lone electron pair. So we will begin an arrow at an electron pair and point it where we want the new bond to form. Let's solve a couple problems to show this better. So first, we have these two reactants and we want to show how this product was formed. And of course, we have to use our arrow pushing conventions to do that. So step 1 states that the arrow starts at the lone pair. So in this case, it will be right here. It's important to notice that this is not the only lone pair in this reaction. We have electron pairs in all of these fluorines. Then two here. But because we know that the product of this is this, we know that both of these reactants are going to merge to form the one product. So it is safe to assume that the electron pair in the nitrogen is going to be our start point, and we're going to end in the boron. So the arrow will go like this. We're starting at the location of the electron pair, and we're finishing where we want to form the new bond. So that is between the nitrogen and the boron. And well, that's how we get this product. Now let's go to problem 2. Our second problem is the ionization of the weak acid HF in water. And we're going to form hydronium plus the fluoride ion. So this one is a little tougher to understand at first than the first problem. And that is because we have more visible lone pairs, more visible electron pairs. However, when you see the reaction, where you're trying to understand it a little better, you can notice that our water, right here, gained one hydrogen to form this hydronium right here. And that our HF is now F minus. So that means that this water molecule probably just took the hydrogen from the acid to form the hydronium. So a bond was formed between the water and the hydrogen, and then the fluorine was kicked out to form the fluoride ion. Let's see how we show that with arrow pushing conventions. So we need to start from the lone pair and end where we want to form the bond. We said that we want to form the bond between water and the hydrogen of HF. So we'll start at one of the two electron pairs on oxygen and finish in H. So that'll go like this. We want two electrons move, so that's why we have two edges. If we finish the problem like this, the result would not be hydronium plus F minus, because the whole HF would stick to the water. So we need to take that fluorine and make it fluoride ion. So that fluorine is going to take one of the electron pairs to become F minus. This F minus is this. It has 8 electrons, and that's why it's negative. Right here, we can only see 6. So the lone pair, the electron pair that was here, is going to move into the fluorine, and then the fluorine will come out. So we would start on the electron pair, that's the bond, and finish where the fluorine is. So just like this. And that's how we show how we obtained those two products. One more key point though. There's a difference between the reaction arrows and the electron movement arrows. And that is just that the reaction arrows are straight and the electron movement arrows are always curved. So thank you for watching this video. I hope you liked it and found it useful. And if you did, please be sure to give it a like and subscribe to see more videos like this one.